Okay guys, so the next question is max chunks to make sorted 2. Obviously this is a Leetcode hard, but I'll be helping you with the logic only, and after you see the logic, the code implementation is very easy. Okay, and it is also a very beautiful logic. So like it can be used in multiple places. This is such a problem that will increase your problem solving capacities, because the algorithm is very clever and it's beautiful, right? So let us go forward. Just like the previous question, only in the previous question, whatever the convenience was given to us, that the elements were in a range from 0 to n minus 1. Here there is no range, so the elements can be anything, and then also you need to do the same thing. You need to return the largest number of chunks that we can make to sort the array, right? I would highly recommend you to watch the previous video, because in the previous video the question was almost same. So there I have discussed a lot of things, so I am just continuing from there only. So you can see only the first line has changed. Over here the first line has changed, nothing else has changed, right? Now after this, let us come over here. Okay, I have already taken an array. So basically over here the elements can be anything, right? And still you need to make chunks, so that individually sorting the chunks should make the whole array sorted. Now the problem is, previously we were considering that if 2 is present, if the maximum present until here is 2, then okay fine, 0 and 1 should also be present before it, because otherwise if 0 and 1 is not present, if any one of them is missing, they need to be replaced by a greater element, then max should have been that and not 2. So that was the main logic behind there, right? But over here, like if we even take the max, we don't know how to compare it, who to compare it, right? So here we need to devise a one level higher to what we did in the previous code. Over here, if you guys observe carefully, how can we find out that at this position, like at over here, should a chunk exist or not? Should there be a chunk that should be existing over here or not? That is something that I want to find out. So how can I do it? How can I check it? Now guys, try to figure out one thing. I'm jumping directly into the logic, that over here, how can I say that I can make a chunk? Now if suppose I am keeping track of whatever is the maximum until here. Okay, 21 is the maximum, cool, no problem. 21 is the maximum until here. Now what I need to check is also that okay, 21 is the highest. Maybe I am considering that 21 will come to this place, 3 over here. So are all the elements that are smaller than it present towards the left only? Then only I can make a chunk. If any of the elements which are supposed to be at the left side are present towards the right, which you all can see is 18. 18 is present on this side. It should have been present on the other side before 21. It is not present, right? So we cannot make a chunk. That is the thing. Let me tell again what I tell right now, that the max until here is 21, right? Until here the max is 21. Also I need to make sure all the numbers that are lesser than 21 in the whole array is to the left of this position only. If they are to the right, I cannot make an array. I cannot make a chunk over here. If I make a chunk over here and sort this chunk, 18 will be left out. So I cannot make a chunk. So if you kind of observe this carefully, then what I did was I compared, in order to make a chunk over here, what I compared, the max from this side should be lesser than the min from this side. The entire right part, whatever the minimum element is there in the right part, should be greater than, this should be greater than the max that is present to this side, or equals to, maybe for example, equals to will also be allowed, right? If there is a 21 over here, then the max is 21 and the min until here is 21. So if they are equal, then also I can make a chunk over here, right? So that is the logic. I need to keep the track of max, and also at all the points I should know what is the minimum to the right of it. Max is from the left and minimum I am trying to find out from the right. And if we find a max at any particular position, the maximum to its left is smaller than the minimum that is present to the right. So all the elements that should be within this range are there. All the elements that are smaller to the max are present to the left only. To the right nothing is present. So if all the elements to the left are smaller than all the elements in the right, I can make a chunk and sort that. Just think over it for a couple of minutes, you will be able to see it, because the logic is, as I have said, it is very, very beautiful, right? So yeah, that's it guys, that is the logic. So programmatically what you need to do is, you don't need to like suppose, let me just give you a programmatic dry run before I actually write the code, and then see. I don't know what will be the result, just made it a random array. Suppose I want to I'm writing the max as well as the mean also I will write. Suppose max is what, until now it is 10, over here 17, over here 21, over here also 21, 21, 37 and 37. Okay, this is the max. And I also need to find the min. Min, how I need to find? I need to find from the last. So for example, min until this index, from right until this index the minimum is 33. Until this index it is 33. Until over here it is now 18. Until over here 15. Then 15. Then over here also 15. Over here 10. This is my min right. Min right. And this is max left. Right. After that, what am I checking at all position? I have told you over here. Okay, I deleted it. The condition that I am checking is, guys, I am iterating from the front and trying to check if my max is less than, or equal to the mean right of the next index, mean right of I plus 1. If this condition is matched, if this particular condition is matching, guys, then only I can tell that yes, I can make a chunk over here. So let us just check, let us keep on checking. Over here it is 10, and the next index, what is the next index basically saying? The next index is saying towards the right of 1 from index 1 to index 5, what is the minimum element that is present, which is 15, right? And the max until over here 0th index is 10. So after this 10, whatever the elements are there, they are all greater than it. So I can make a chunk over here. So I can make a chunk over here, right? Over here I can make a chunk. After that, it is 17 over here. The max until here is 17, and the min until the next position is 15. So I cannot make a chunk over here. After that, 21 is over here. Max is 21, and the min to the next until the next position is 15. So 21 is present towards the right, and after this 15 is present. How can I make a chunk? I cannot make a chunk. So I move over here. The max until here is 21, and the minimum until here is 18. So again, not possible. 21 is greater. It should come towards the right. How can in the right a minimum element be present? So again, we check for the next index. So this is 21, right? Here it is 21, and the next element, the minimum is 33. Okay. So now I can make a chunk over here. Over here I can make a chunk, no problem. Then the max is 37, and the next minimum is 33. How can I make a chunk? I cannot make a chunk. So over here, as I am checking I plus 1, I should run till n minus 1 equals to n minus 1. I should run. I mean less than n minus 1 I should run. So if I am running for less than n minus 1, my iteration will stop over here only. This is not a chunk. Sorry, this is not a chunk. I am saying that my iteration will end over here at this position at index 5 n minus 1. And obviously we know that compulsorily at the end we should make a chunk, right? That is why the value of chunk you can just initialize that with 1, or at the end you can do chunks plus plus denoting the last one, because we are checking this condition which involves I plus 1. I cannot go travel till the last index. So you can just travel until here, and the last one is by default, it will be present everywhere. Even if there is one chunk only, it will be the last one only, right? So basically how many chunks we have created? We have created 3 chunks. One is this chunk, one is this chunk, and one is the other chunk. If I sort this, obviously this is one element, single element. Okay. If I sort this, it will be 15, 17, 18 and 21, and if I sort this, it will be 33 and 37. So the whole array will be sorted after sorting the chunks individually. So the maximum chunks that are allowed is 3. And remember, if you are just making this logic and working on this logic, then you need to add a chunk at the end, or you can initialize chunks with 1. Whatever your chunks will come from this logic, 1 extra should be added denoting this last one, which was not checked because we are running till n minus 1. the logic is beautiful. Obviously, if you are not able to do it guys on the first go, if you are unable to develop the logic on your own, don't worry about it. It is a Leetcode hard. Cool. You are lucky that you are doing it now, you are not facing this question in the interview, right? So it's okay. Maybe you have not devised the logic on your own because it is tricky, right? It's not that easy, but okay, no problem. Once you see the logic, you cannot unsee it, and maybe you will be facing a similar question in your interview where the logic building will be improved because you already know this kind of logic exists from before, right? Cool. Let's write the code. I hope you will pause and try to write the code on your own. It is pretty simple. So over here also I need to take a chunks variable which I can initialize with 0 or 1. At the end I'll do the plus thing. Okay. So and after that I'll just take the length of the array, right? After that one thing guys, just one coding optimization is that I should not make this array, I should not make it. I can make this array, and I just can iterate through from the front, and while iterating I can take this max as a variable. Max left can be a variable which will keep the track of the maximum, and this array mean right will already be made. So real time I can perform this condition check, right? I hope the point is clear. I'll write the code, you can understand, you can make both the arrays, but I'm just trying to optimize the space a little bit by saving the space of one array. So I'll make an array right mean, r mean for example, r mean, which is of size n only. After that I need to store all the minimums. So I'll iterate from the back. Int I equals to n minus 1, I must be greater than equals to 0, I minus, right? And over here I need to I need to take a variable mean, right? So int mean equals to, I can give it integer dot max value. After that, if we find an array of I which is less than my minimum, then I should update my minimum to error of I. I'm just finding the minimum at the beginning of the iteration, at the beginning of every iteration, and after that in this rmin array of index of I am assigning this mean. The value of minimum will be assigned every time. This is how I am basically making this particular array over here. This right mean I am making. After this array is made, I will just iterate through and try to find out which one is the max. Like I'll take a variable max, int max equals to integer dot min value, right? After that what I do, I iterate from I equals to 0 to I less than guys n minus 1, not n, because otherwise I'll get an array index out of bound exception, because in my condition I am checking the next element, I plus 1th element of r mean I am checking, so I cannot go till n, right? So over here what do I need to do? Again I need to first calculate what is max. So max will be equals to, let's use ternary operator for example. If my ARR of I is greater than my max, if this is the condition, if this is true, then max will be assigned with ARR of I, otherwise max will be assigned with the previous max, whatever it was, right? After I find the max, I need to find out if I can make a chunk. If what is the condition? If the maximum that I found till now, if this max is less than or equal to r min of I plus 1, okay, to the next index, until the next index is if the minimum found element from right to that particular element is less, I can make a chunk, right? I'll do chunks plus plus, right? And I think that's it guys, that is the whole code. And after that, remember there is a chunk that should be added at the end, which I need to add, and then I'll return these chunks. As simple as that. Filling the min, calculating the max at every iteration, and then checking if chunk is possible, adding a chunk at the end, and then returning it. As simple as that, beats 100%.